Molarity is the unit of measurement for how concentrated a solution is. So the word concentrated and molarity really mean the same thing. And the equation is capital M is measured by moles per liter of water. So as long as you have two of those units, you can always solve for the one that you don't know. For example, okay, we're pretty much starting as easy as it gets here. What is the concentration, which means what is the M of 2 liters with 8 moles in it? So that would be M equals, 8 moles over 2 liters, which means the answer is that the concentration is 4 molar. Okay. What volume? We've got a capital M. We have 5 moles of glucose. So here's our equation, moles per liter. Okay, this is going to go here, and that's going to go there. So that means for what volume we're solving for liters. So we have 2.3 equals 5 mole over L. Okay, this is the most common way people make mistakes because they just want to multiply to solve. But you can't do that if the unknown is on the bottom of a fraction. So first, I'm going to multiply both sides by L so that this cancels out. And now we have L times 2.3 equals 5. So really we solve by dividing, not by multiplying. And the answer is 2.17 liters. Okay. So if we're solving this one, there's a little bit of a trick to this one. So our equation is moles per liter. This is supposed to be capital M here. So we have 1 molar solution, which would go there. Okay, the question is asking for moles, which means that this is going to be our X because we don't know how many moles there are. So this is the problem. It gives us 500 milliliters instead of 500 liters. So we have to convert from milli to liter first before we plug it in. And the way that we do that is milli is 3 steps below regular liter on the metric staircase. So that means we would do 500 divided by 10 to the third, or 1,000. So 500 divided by 1,000 means that we have 0.5 liters. So this is going to be 1 molar equals X moles over 0.5 liters. Okay, now the X is on the top of the fraction, so we do just multiply both sides by 0.5. So the answer is 0.5 moles. Okay, so here is where we incorporate mole conversions with this. So we just figured out that we had half a mole of salt. If we want to know the mass of that, we have to add up the mass of what 1 mole of salt would weigh. So we look at the periodic table. 23 plus 35.5 is 58.5. So if we want to convert the mole, the half a mole of salt, we would do 58.5 grams for every 1 mole and get 29.25 grams of NaCl. Okay, so sticking with the same thing here, moles per liter. You got to look for what you have and what you don't have. Okay, it looks like it's asking for concentration, so that means this is going to be the X. Okay, we have 1.5 liters, so that will get plugged in right here. Okay, now this is an issue. Okay, you cannot plug grams in for moles. So that means we will have, oh, this is supposed to be KNO3. Whoops, my bad. So we're going to have to figure out how many moles are those 6 grams. So we need to do a conversion before we can plug that in. So we have to do 6 grams. Okay, we know we want to know what 1 mole weighs. So in order to get rid of grams, you have to divide by grams. So we need to add this up. 39.1 plus 14 plus 3 times 16. And it's 101.1. Okay. So 6 divided by 101.1 is 0.06 moles. Alright, so we got that out of the way so that we could plug this right here. And we would solve by 0.06 moles divided by 1.5 liters. So the answer is 0.04 molar. Okay. Moving right along, milliliters, again, that's an issue. Okay, we need it to be regular liters, but capital M is fine. So here's our equation, moles per liter. Okay, this is going to go here, and this has to be converted to be plugged into there. So 750 divided by 1,000 is 0.750. So we have 0.5 molar equals X moles over 0.750. Since X is at the top of the fraction, we can just multiply both sides by 0.75. So we have 0.375 moles of iron chloride. Okay, the question is, what is the mass of that solute? So that goes back to the question I did a few minutes ago. What was the mass of NaCl? If you want to know grams, you need to multiply by grams. So we need to know, what does 1 mole of iron chloride weigh? And if you add it up, it is 162.35 per whole mole. So 0.375 times that would give you the answer, which is 60.9 grams. Okay, almost done. So the difference between concentrated and dilute. Concentrated implies that there's a lot of solute and only a little bit of water. Dilute means a lot of water and only a little bit of solute. So if you look at the picture, okay, if the purple represents the water, okay, in this picture there's a lot more water and there's a lot less blue, whereas in this picture there's a lot more blue. So to dilute something means to add water to it, which means you're not losing any of the solute particles, you're just making them more spread out. And the equation for that is initial concentration, initial volume, is always equal to the final concentration and the final volume. So 1 stands for starting numbers, 2 stands for final. So in this question, okay, we have a starting molarity of 12, okay, and we want to know how much of that 12 molar solution do we need to dilute it down. So we're always going to end up with a lower concentration and a higher volume. So we know we're starting with 12, but we don't know how much. Okay, and on the other side, the M2, this is M2, this is M1, V1, okay, and the V2 is 1,000. So we just really need to multiply and divide to figure out how much of that 12 molar we need in order to dilute it down to those numbers. So 1.5 times 1,000 divided by 12 means we need 125 milliliters. Okay, so in this equation, it does not matter if you have milliliters. You can use whatever volume. So what we're saying is, if we had, let's say we had a bottle of this strong stuff in the back, you would take 125 milliliters of it and pour it into a beaker and then add water until you had 1,000 milliliters. So we're literally just figuring out how much of this we need, and then the next step is add water until you get your desired volume. Okay, similar question, different numbers. So what volume? Here's our starting concentration. Okay, and the reason I know that's starting is a couple reasons. One, this says we're making this. So that implies that this is the M2V2, okay, M1V1. The other reason is because I know I always start with a higher M and end with a lower M. So we're going to end up with 400 milliliters, and we want it to be 0.6. Okay, and we started with 5, but we don't know how much we started with. Multiply and divide. The answer is 48 milliliters. So that means we take 48 milliliters of this, add it to an empty beaker, and add water until we have 400 milliliters. And that takes the concentration from 5 down to 0.6. Okay. Last two questions. So this directly tells you that you're solving for the final concentration. That's the M2, is what we don't know. Let's see. The M1, V1, M2, V2, okay, says that we take these numbers and we dilute them down to 5 liters. So that means we don't know M2, but we know the final volume is 5. Okay, we start with just 1 liter, and the concentration is 5. So even though the unknown is on the other side, it does not change the math. Multiply and divide. Okay, 5 times 1 divided by 5 means the new concentration goes down to 1 m. Okay, last question. Okay, this one's a little bit different because it's asking how many milliliters we're going to add to what we're starting with. Okay, so let's just set it up the way we've been doing all the other problems and then talk about what the difference is there. Okay, it says we're trying to figure out how much water we're adding to 150 milliliters of 1 molar if we want to dilute the concentration to 0.25. So always higher molar before lower, so that means we're starting with 1 molar and 150 milliliters of it. Okay, we're diluting it to 0.25, so what we don't know is the final volume. So multiply and divide so that we can get V2, which is 600. So that's almost the final answer. If this question had just said, what's the final volume, then that would be it. But this question's asking how much did we add to what we started with. So it's just asking the question in a different way. We started with 150 milliliters. Okay, we took that 150 and put it in an empty beaker, and then we just added water until the line went up to 600. So we didn't add 600 milliliters. Okay, we did 600. We started with 150. So that means we added 450 milliliters to what we started with. Okay, so sort of the same question, just asking it in a different angle.